Okay, hello again. We'll get started. My name is Andrew Bromley and I'm the chair of the Yorkshire Northern area of the IMA. And welcome everybody to this event. I'd like to thank you all for taking the time out to attend. If you can just keep your cameras off and your microphones muted for the duration of the presentation, that'll just help with picture quality and stuff like that. We're recording the event tonight, so we'll be able to share that with people afterwards. What else? Yes, I've just said that. So we're going to take questions at the end. So if you've got any questions as we go along, you can always put them in the chat. And then at the end, if you raise your hand, we'll come to you and answer, and you can ask your questions directly. So yes, it gives me great pleasure to welcome Dave Cliffe from Yorkshire Water. And he's going to be doing a presentation about risk-based inspection of submersible pump chains. Dave is a member of our committee, so it gives me great pleasure to hand over to Dave. Thanks, Dave.
Good evening, everyone. I hope you're all well. I shall just share my screen. Can everybody see the screen okay?
Yeah.
Yep. Thank you. Thank you, Andy. Sorry, everybody's on mute. As soon as I said that, I realised what I'd said. Yes, thanks, Andy. Yeah, hi there. I'm Dave Cliffe, Principal Mechanical Engineer for Yorkshire Water. I've been at Yorkshire Water either directly or indirectly, man and boy, from being an apprentice maintenance fitter way back when in the 80s. So what I'd like to do is just take you through how we identify the opportunity, and we developed and implemented our risk-based inspection program for our pump lifting chains, which come under LEAH. So I'll take you through a bit of an introduction. The installations are in, how they're configured, how they're used, some of the challenges we faced and the objectives we set ourselves for this, and also the solution we developed, its delivery into the business, and also the outcomes. Okay. So really, as an introduction, I thought to myself, really, obviously, I know this business quite well. I should do after 30 years, but obviously some of you guys and the girls will not have seen the water industry, sort of given a bit of an overview. So Yorkshire Water obviously operate across the whole of Yorkshire, which is more than 4,500 square miles. And within this area, we have over 8,000 submersible pumps. Now, most of these pumps are in what we know as wet well pumping stations, and there's a roughly 2,400 of these submersible sewage pumping stations. The image on the bottom left is a typical illustration of a relatively small sewage pumping station for a housing estate, which developers can install if the lie of the land is below the main sewer. And also in the middle is some illustration of typical submersible pumps, which I'll go through in more detail in the next slides. So I thought I'd try and give an illustration of the size and range of pumps we operate. So we go from really 20, 30, I've said 50 kilos there, 50 up to over 7 ton in weight. And it gives you an idea, a visual idea of the size of the pumps. The vast majority of our sewage pumping stations are towards the small end, 20, 30, 50, 70, 100 kilos in weight. Some of the bigger drives are talking 250 kilowatts, quarter of a megawatt. So we'll move on. So we're back to this picture here, and it's really just to build a little bit more on these sewage pumping stations. Same image again on the left. I put a blue circle around it. The image to its right with the 2 red arrows shows a relatively small diameter, reasonably deep sewage pumping station, and a very clean one, I must say. The chains you can see attached to the pumps and suspended from the hooks at the top are the submersible pump lifting chains, and I'll come into those a little bit later. The reason they've got chains attached is so we don't have to go into what's classed as a confined space to recover the pump. They do auto decouple from this pipe work here, and they auto decouple when lifted, detach from what's known as a duck foot bend, and we can lift them out of the wet well using the chain, and they run up these guide rails. Obviously, in reverse, we can put them in These pumps can also be found on what's known as terminal pumping stations, which lift the sewage onto the treatment works for gravity treatment, but also pumps are any submersible pump on a treatment works for mixing and pumping returns. So I wanted to really look at a simplistic view of a cross section of a wet well pumping station. Obviously, up here is ground level, and what we have is normally two pumps within a wet well. In this image, obviously one behind the other. So what happens is the chains are permanently attached, as we say. At the top here is an ultrasonic level detector, which is looking at this level in here. And when the level rises to the point where the pump starts, the pumps start to run and pump the effluent down out of the delivery pipework and away to the sewer or the treatment works. The pump then stops. And obviously this is a bit of a time lapse really, because it's not as fast as this. The wet well fills back up again to repeat the cycle. Now these pumps run in batches, obviously pumping between stop and start, and this is quite important for later on, because when the pump is operating, there is a small amount of vibration which can be passed on to the pump chain, which is permanently attached to the handle. Okay. So we may be thinking to ourselves, why do we need a submersible pump chain? Why can't we just use a normal lifting chain? So I've tried to illustrate here with the lifting device that's over the wet well, because as we say, this is a quite a small wet well. You can see the size of the man or the person at the top, and we can see that there's a jib crane there. Now that dimension A is the limitation of how far you can lift each time you lift the pump, because obviously you'll hit the lifting beam. So what you need to do is you've got a submersible pump chain that's made up of master links and chain link joined by intermediate links, which enables us to do what's called a snatch lift. So you'll lift, hold a chain, lift, and you can take it out in stages. Some sites, these aren't installed and we have to use cranes for the bigger pumps or other lifting devices. So that gives you a little bit of a background to what's typically a sewage pumping station and certainly a submersible pump. So some of the challenges and objectives we set ourselves here is we had a mixture of legacy stainless steel and also galvanized carbon steel pump chains in the business. We had some incomplete data, so length of chain, manufacturer. We had incidents of chain corrosion, and we can see that this quite a large lifting chain off this interstage pump here. This is a galvanized chain. The galvanized protection is broken down, and we're seeing corrosion in around the welded area of the link. The chains were not tagged, which means that within the business, within Yorkshire Water, operations and maintenance colleagues go to site and they do not use any lift equipment that's not tagged with the next inspection date. So some of these older chains were not tagged, even though they had certificates for them. And we had an existing or unverified written scheme of examination, which means it was applied at the time, but it wasn't following best practice. So that was obviously a challenge we need to face into. So the objectives we set ourselves was really to have an exclusive base or asset base of stainless steel chains. We really wanted we must have accurate asset data, because that's one of the requirements under LEAH. And obviously to enable to manipulate data and understand risk, you need the asset data. We need a sustainable, repeatable inspection program. We need to improve first time fix, because there was occasions when colleagues would go to site to remove a pump for a blockage or to do maintenance that the equipment wasn't in date, which means they had to get it inspected, which means a second visit. And obviously we really wanted to apply industry best practice. So if we think a little bit about LEAH, and under LEAH Regulation 9, we need to do a thorough examination and inspection of our lifting equipment. And depending on the equipment under LEAH, depends on the frequency. So if it's actual class as lifting equipment, which is fixed cranes, overhead travelling cranes, beams, that needs to be inspected a maximum of every 12 months. And lifting accessories obviously is something that attaches the load to the lifting equipment. So these are chains and shackles and slings, and they're every 6 months, but again, a maximum frequency of inspection. Because we've got over 6,500 chains, that would require an average of 250 chains a week to be inspected, because they need inspecting twice a year. However, under the legislation of LEAH, there is an alternative, and it's known as a written scheme of examination. So written scheme of examination enables the user or the owner of the lifting equipment to apply either a longer or shorter periodic examination. But if you go longer, you really must have risk-based approach, and you must have a rigorous assessment of the risks and how the equipment is going to be used. Now, the main chain supplier that we've used is William Hackett's, and the William Hackett's manufacture high quality chains and the main manufacture 316L grade stainless steel chains that we use. And William Hackett's, in conversation with us, identified that LEAH, and LEAH, the Lift Equipment Engineers Association, which is the largest lifting association we have, was working with other companies, and they were working across the industry with inspection bodies, so Allianz, Cornell, Zurich, Atlas, Velocity, who are our competent body. They're working with the HSE, they're working with chain manufacturers, William Hackett's and other water companies to understand and how we can apply risk-based inspection program, or WSE, to our submersible pump chains. So we all had a meeting in Huntington, and we all came together and we worked and we scoped and drafted and reviewed and finally published 2 documents in December 2016. And these 2 documents were a guidance to producing a written scheme of examination for submersible pumps, and also the specification for pump chains. So think about what's in the guidance. The first document, which is 069-1 from LEAH, this identifies when it is not appropriate to do a written scheme of examination. Provides an overview of the methodology applied, so this risk-based approach, and understanding the asset and its location, and also enables the scope of the risk-based methodology that needs to be applied. Now, the little screenshot at the bottom is one of engineers' favourite things. It's a spreadsheet, and on the spreadsheet, what we did have, we were building a really accurate list of all our submersible pump chains, and all our pump chains had a unique Yorkshire Water lifting asset number, which began YW. So, for example, YW0269 was a particular chain, and each one of the lines, the 6,500 lines produced, was a chain within our site. But at the time, we were still using an unverified written scheme of examination, not against the latest LEAH guidance. So think about the specification document. This clearly sets out the materials and the grade of the chain to be used, the working load limits, the quality of the product and any chemical information, chloride levels and pH levels, and also the marking of the chains and the assemblies. The one thing to note is because the chains that's permanently attached to the pump handle, is that the shackle, the D shackle, cannot be a normal pin shackle that can unscrew under vibration, which obviously the pump produces some vibration when operating. What it must be what's classed as an E-type shackle, which means it has a thread with a nut and a securing split pin. That also means that the D shackle can be classed as part of the chain. It's not a separate assembly. So when we're looking at written schemes, there was really 2 things we must consider. We must have historical evidence. We can't just start producing a written scheme with no evidence to base it on. And the other thing we must do is we must understand how and where these chains are going to be used, which would form part of the risk-based inspection program. So let's first think about the historical evidence. What could we do? Right back at the beginning of the presentation, I talked about we did have a legacy of a large asset base of stainless steel and some galvanized chains. And these stainless steel chains, which were grade 50, had been in use for 3 to 4 years. So what we did, we looked at the asset base that we had, and we identified a range of chains across a range of safe working loads and lengths and sizes. And then also we looked at geographical locations and the type of installations that were used on. And we removed some of these chains from service, installed new chains, and they were sent back to Germany to the manufacturer for forensic and destructive testing. The results that came back from the initial 12 chains that we sent away came back, they were good for service for another 2 to 3 years minimum. So that enabled us to start building a legacy of a portfolio of evidence for these legacy chains. The next thing we needed to consider was how and where these chains would be used. So what I've tried to show here is the methodology behind producing this risk-based inspection program. So we had on the left a large amount of chain data and also the process type of data, so where these pumps were installed, coast, inland, sewage pumping stations, storm pumps, and the bullet points in the second box really looks at the type of information and the risk-based approach we were taking. So it's service, whether it's clean water or waste, the pump's weight, whether the pump was less than 80% of the safe working load or greater, the grade of the chain, the flow, and the type of system. And to that, we built an algorithm within a spreadsheet, and we applied a weighting factors to these within the algorithm to put weighting to these attributes to chain. And that produced a frequency of examination for each chain, which was rounded down to the nearest 12 months. And that also tied in with the written scheme of examination that was produced. So the image on the right is a screenshot of some of the data from the 6,500 lines of data we had for the 6,500 chains. And the blue circle highlights on the left the data that was used and the algorithm that produced the information to produce the frequency of examination. So we can see here that we have some grade 5 chains. They're on site pumping, and it calculates that it's 36 months. So we've got a storm pump that should be inspected every 48 months. And the reason the difference is because the storm pump only operates when the storm conditions. So most of the time, a storm pump is not operating. So the amount of wear and the amount of use of that chain is far less than a normal sewage pumping station. So these chains and the algorithm was used to calculate these frequencies. What we also did in the note down here is because we were looking at these chains every 3 to 4 or 2 years, depending on risk, instead of every 6 months. We wanted a selection of chains to be audited every 12 months from a range of installations to make sure that we were correct and the chains weren't wearing faster than we expected. So there was 2% of the 6,500 were programmed in for removal and inspection every 12 months. So pulling all that information together, we've got the historical evidence from the destructive and forensic examination of the chains that was sent to Germany. We've got the risk-based inspection program in the middle, and we have the written scheme of examination that was drawn up with our competent body, Applus Velocity. And the written scheme of examination stipulated the frequency of inspection for a type of chain, and it tied in with the risk-based inspection approach in the middle, and that gave us our RBI program for the pump chains, and obviously following LEAH's best guidance. So we move into the implementation phase now, how we actually delivered this into the business. And the first thing to talk about really is what we class as service delivery. And service delivery to us is our operational colleagues who actually operate, maintain the plant, and also under service delivery is our maintenance teams. So the mechanical fitters who go to site and pull out the pumps to repair them or replace them if they've failed. So we looked at how we would engage this and how we deliver this into the business. Obviously, it is quite a change from them expecting their pumps to be pulled out like any other lifting accessory and inspected every 6 months or against an unverified written scheme. So what we did, we set up a dedicated support team within we have a compliance team who deliver regulatory compliance, asbestos, lifting, LOLA, and we had a dedicated team, or somebody within that team, should I say, apologies, who actually delivered that compliance. We also work quite close with one of our mechanical partners to install new chains, pull the chains out, and work with the inspections from Applus Velocity and other partners to inspect the chains before they were returned to service. We produced toolbox and safety talks, which was rolled out to the business to explain what was happening when it would happen. And we also, because of the chains that I mentioned earlier, some of the legacy chains did not have a next date inspection tag on them. And this was initially causes problems because people going to site at the middle of the night, getting call out to 2 o'clock in the morning to attend site because of a blocked pump, they'd look at the chain, were unable to verify whether that chain could be used to lift. But we knew that the pump chain had its unique reference number on its YW or its PC, or pump chain reference number. So we developed an app looked at the SharePoint site with all the data, and the operator or maintenance colleague inserted the number in here, in the PC number and the chain number, pressed enter, and it returned all this information. It looked at the date of inspection, confirmed the site it was on, and gave a green light or a red light if the chain was used. And over time, these chains without tags on are either getting inspected and re-tagged or getting replaced. So this pump chain checker tool we developed has been extremely useful. So next is the implementation phase for the inspection. Now, initially there was some initial some uncertainty how and where to measure the pump chains, because what we're doing, we're measuring one or 3 positions along the chain. We're measuring one of the short links that forms a short link of the chain, the meter length. So what we produced was a location and measurement guidance document, which instructed the user how and where on various lengths of pump chains where to measure them and what information to record, and that information is fed back into the inspection teams and is used for verification and calibration of the risk-based inspection tool. So if you think about inspection, one of the additional advantages of, because we have to pull the pump out to inspect the pump or replace the chain, the one thing we're also able to do was to provide verification of the data off the data plate of the pump, because it also enables to verify the accuracy of our asset base of pumps. Now, this video I've used in here again, the one that we're recording something called the static load and also what's known as the breakout weight. So when the pump's in the wet well, it's on its duct foot bend, it's connected and coupled to the discharge bend. Now, if these pumps have been in for a while, they can get stuck on this bend. So the breakout force can be higher than the actual static load of the pump. It was just hanging from the chain. So when that pump starts to lift, that initial breakout force can be higher. So using load cells, the inspection teams recorded both the static and breakout weights, and that information is used to feed back and verify the chains and also the loading on the chains. And also, as I say, we're able to verify the pump asset data. So implementation, we've implemented it. We've got a really stable written scheme of examination, risk-based, and we're also thinking about the next steps. Now, this screenshot you can see here is something that we've developed within the asset reporting team. And because what we were interested in is a bit like servicing of a car, it's either 2 years or 20,000 miles. We wanted to make sure that the inspection program was based upon vibration, because what can cause these chains to wear is the pump oscillating and vibrating the first meter of chain. Because some of these sites, it's very, very rare for these pumps to be lifted out, and to be fair, some sites can be quite frequent. So we weren't overly concerned about lifting the pumps and using the chain 20-30 times a day like a lot of lifting equipment can be, because of the use is quite infrequent. What can wear the chain is the pump running and vibrating. So what we've developed is, using data from our data team, is we've input the last inspection date of the chain and its next inspection date based on a risk-based inspection program. And for every submersible pump within Yorkshire Water on a sewage pumping station, we calculate the hours run, because we can equate the hours run to the amount of potential wear of the chain. So we're developing this. We have it built now, and we're just about to start looking at implementing it and monitoring the chains. And this report could be run every month, and we can look at areas of the business or specific pumping stations. Another bonus that was noticed when we developed this is we've got 2 pumps here, pump 1 and 2, on a site. Both were inspected at the same time, but we have one pump that's run 3,286 hours and one pump that's run 3 hours. Now, there may be a genuine reason for that, but also there may be a reason there's an issue with the control system for the pump station. So what we're doing here is overdriving this pump and wearing this pump out, and this pump doesn't really run that often. That's a bonus or something additional to what we were actually designing the pump chain maintenance report for. So that's something that we're looking to implement. So if we think about the HSE and the plan, do, check, act circle, constantly checking, constantly improving, we'll look at each stage. So we've been through the planning stage. We've built the chain data, gathered the data, produced the RBI tool to the LEAH guidance, and we've scheduled we're constantly scheduling chain inspections. We've been through the do phase. We've delivered the inspections. We recorded the data and also verified our pump data for our asset base. So the next bit really is to check and review. We need to use that 2% chain inspection, and also the inspection data coming back, the measurements of the links, checking for wear, looking for elongation of the links, and also to recalibrate the tool. So if we think about the original RBI tool and how we developed it, and we have this data, what we're doing now is we're taking the information we've recorded on site and feeding it back in. So we're taking chain testing data, inspection, and also we will be taking the hours run information when it's implemented, and we're calibrating this tool. We're making sure that the algorithm has calculated the correct frequency of inspection. And what we're finding is that the chains have been in 3 years. We've removed the chain, we've measured the short link, and there's no visible wear at all. So what we're looking to do is using that, increasing our portfolio of evidence with the chain testing, using information that's coming back, and also we're also removing other chains for destructive testing. So we're constantly building those test reports from Germany, forensically and actually physically breaking strain, bending tests. We're taking all that information, coming back and recalibrating to ensure that our written scheme is accurate. So outcomes, where are we now? So we've got what we wanted. We have an exclusively stainless steel chains. We have a comprehensive RBI, a written scheme of examination for all our 6,500 pump chains. We have an accurate asset data, not only for the chain, but also for the pumps on the end of the chain. And accurate data to us, as in in any business, is absolutely fundamental. If we know when we go to site which pump is in the ground, that enables to take us a spare pump from our logistics centre and swap the pump out. And that's a first-time fix. This reduces the risk of pollution for us. It improves the first-time fix, not only attendance, but also planning it. And actually, it's improving colleague morale, because they know when they go to site, the pump chain's in date, they know when it's due to be inspected, and also when they go with the pump to swap the pump out that's failed, they can use the chain and they can achieve a first-time fix. So one of the main outcomes, if we go back to the original slide from earlier on, and we looked at 6,500 chains, that was 250 chains a week. Applying the risk-based inspection program and extending the period of inspection has enabled us to reduce that to an average of 54 chains a week. So that's a 70% reduction in the greater, sorry, than a 70% reduction in the number of inspections that we have to do each week. That reduces labour time. It reduces the risk to the process because we're removing a pump. It improves and actually improves the safety of the asset base. So that was it. It was quite a brief presentation. Is there any questions?
Dave, I think that was brilliant. It was, yeah, fascinating. I didn't quite know what to expect. But
it wasn't that.
Well, no, I didn't know what to expect. But that was fantastic. You've covered a lot of facets of the chains and how the inspection is, etc. So yeah, fascinating. We did have before I open it up to everybody else, we did have one question on the chat from John Holmes asking if it's feasible to use modern composite fibre rope instead of using chains.
I think the problem with fibre rope is its longevity, and obviously it's permanently submerged, and it's permanently submerging products that can have on certainly coastal installations. We've got high saline levels or high chloride levels, and it's sometimes hard to ascertain the condition of the type of ropes I'm thinking of. Where a stainless steel chain or any chain, but we wanted to go for 316L because of its longevity in application and the resistance to corrosion, is we can actually pressure wash them. Because you've got to bear in mind that these images I've shown you here, the nice one on the left at the bottom there, and that what I describe as a clean wet well.
Yeah, very clean.
That was very, very clean. Some of these wet welds you don't want to be looking at before you eat your tea, and some of these chains that take out have to use high pressure washers to clean the detritus off to enable you to get anywhere near the chain to measure it. So it's an industry standard to use a stainless steel chain. It's something that we had considered for a short period of time, but we were concerned about its longevity really, and ascertaining its use completely submerged permanently under sewage, or under some of our sites have got some chemicals in them from industry as well. So when we're talking about the pH levels under the LEAH document, it's quite it's quite a specific range of chemicals, because you've got to do things like Bradford and Leeds and Sheffield. There's discharges from industry into the sewer which we need to pump. So we need to be certain that chain is fit and resistant to what's coming through the sewer.
Yeah. Okay, thanks.
Question.
Got a question from Daniel Hopkins. Do you want to come off mute and ask your question?
Yeah, thanks for that. It was very interesting. We did have a failure about a wire rope sling of a similar kind of setup just before Christmas. So it was very interesting to see your setup. But we only have about 5 or 10 of these pumps. Obviously, you've got a lot of these, so a massive benefit for you guys to do this. Do you think it would be as much as benefit to us with only having a small handful of pumps?
It depends on your operational setup and how easy it is for you to pull them out. We did have something called a blue rope system, which means that the chains were not submersed. The chains were left on the top, a chain was left on the top, and the blue nylon rope was threaded through the handle of the pump, and it was tied at the top, so it was like an endless rope. And then what you did, you used the rope to thread the chain hook through the handle and then retrieve the pump so the chain wasn't submerged. The problem with that, with the sewage pump inside, is that certainly on raw sewage pumps, there is an awful lot of rags and detritus in that sewage. And sometimes there was that much clung to the blue rope that it was physically impossible to use the system. So we used to have a blue rope system, and for certain types of installation, but we've prohibited that use with our engineering spec. We've actually removed that from the spec now. So we've gone predominantly for stainless steel 316L. But it depends on the number and type of installations you have. I suppose operationally, how long you can have the pumps out, whether you've got lifting davits or frames there. It'd be an interesting one to do, because anybody can produce a written scheme of examination. That you're allowed under law to produce a written scheme of examination, but you've got to start with the evidence and build it. I assume you've got do your inspection of lifting equipment in house, or do you use like Zurich or Allianz?
We do it through Tusk, which is a subsidiary of Mammut.
All right. Okay. So they're like a competent body to you inspecting the lifting equipment. I mean, that's something that they should be open to discussing with you. And the algorithm sounds quite fancy, but it's genuinely not. It's a typical spreadsheet with all the attributes in there. And when you choose an attribute, it puts a weighting factor against it, and it works out the risk. And then it looks at the months and rounds it up or down depending where it is. So it's relatively straightforward, but it's like anything in Excel, extremely powerful once you've copied it 6,500 times. We did ask the question initially, and they were very, very reluctant to come away from the kind of LOLA guidance of 6 months, and that's kind of it. And in the end, we went for the manufactured a bit of a long pole with a hook on the end to try and get the to go fishing for them. Yeah. What kind of product are you pumping?
It's a really nasty effluent, so we've got to be really careful on our pH level. It can get quite acidic. So we've changed the way we monitor the pH. It was getting sampled manually. Now it's done a different way, and it's done daily. So we've got a better eye on that. So we're not getting as bad damage on the pumps and stuff, but it can get quite bad. So we've seen a lot of damage in the past.
I can see that option of having a chain at the top, a bit like our blue rope system, but like a blue hook system, and effectively and attaching the pump that way. That sounds a reasonable way of doing it. I suppose then you don't have to the asset base, because even though you've only got, like you say, 6 pumps. Apology, I think you said 6. You only have to have one a chain effectively, then, don't you?
Yeah.
Okay.
Thank you.
No problem. Thank you.
Brilliant. We've got quite a lot of questions in the chat now. Philip Ashcroft used to work with you 13 years ago. He says hello.
Hi, Phil. Yes, you did.
John Robinson, what is the maximum periodicity you are looking at?
Hi, John. Well, it's currently set at 48 months, but through the calibration that we're looking at now, we're looking to extend that maybe up to 6 months, up to 5 years. But we're looking at it now to move if it's a 3-year chain, is move it to 4 years as a minimum, because what we're seeing virtually no wear on the chains. But obviously we've got to take those. We've got that 2% calibration list, and we're also taking chains out because it may visually look good, but we want to make sure that it's not, the material of manufacture has not been affected by the pump's product. So hence the sample of chains. I think another 10's gone away back to Germany, where they do the full forensic and destructive testing, the load test.
Okay, brilliant. Sheldon Parker. Hi, Dave. You mentioned that you took into account vibration in the algorithm. Is there also an element of the liquid meniscus accounted for, or rising and lowering scum line, or is this accounted for in the hours run?
No, I think what it is, Sheldon, is because it's stainless steel 316L, we know that it's a pretty inert material. No matter in what environment it's in. We've got some of these chains obviously on the east coast around the Whitby Scarborough area, and we're seeing no detrimental effects, even because some of our older sites obviously built around Victorian sewers. So sometimes we get exceptionally high tides, we do get ingress into the sewers because of the condition of the old brick line sewers. So we find that we are pumping sand, high chloride levels at high sea levels, and even those sites, it's not really affecting the pump chains at all. So the condition is good. So the level or the rising level of the scum level, we're not overly concerned about that.
Okay. Oliver, will the new risk-based inspection provide cost savings, and if so, what magnitude of the cost savings do you hope to achieve? You've obviously told us about the reduction in the amount of
what LEAH said is when they were working with the HSE and we had an initial meeting at Huntington, what they were saying is the HSE, you can put a written scheme in there, but it must be a risk-based approach. The approach that other water companies and the one we had at the time of a blanket approach. So we had a blanket approach, and it was from another insurance company of 5 years blanket, is that you can't do that because it's almost putting profit before safety. It must be a risk-based approach. From that point forward, we worked with LEAH to develop, along with other water companies, not just ourselves, and obviously the chain manufacturers and the insurance companies, to produce that risk-based inspection program. There is advantages. Physically inspecting 2,500 chains a year, or produce, sorry, the 6,500 chains twice a year would be a phenomenal task. We'll do them every 6 months. So yes, there's a greater than 70% reduction in the number of chains. The figures I can't remember. There is significant savings, and I do apologise for that. Obviously, the 316 stainless steel chains are a lot more expensive than a galvanised steel chain, but we don't want galvanised steel chain basically because of corrosion issues, and we have had chains fail before. So because of submerged, you can't see them. You can't carry out and it's accepted, you can't carry out your normal pre-use examination under LEAH, which is a requirement because half the chain is submerged and you can't see it. All you can do is examine the chain and slowly lift the pump out the wet well, examining the chain at the water line, making sure everything's okay. And the advantage is the pump and the load is always below your feet until you get it onto the surface. Yeah. So yeah, there is advantages. I'm sorry, I can't remember the figures, but there is obviously associated savings, not only with operational time, associated with putting the risk-based inspection program in.
Yeah. Okay. Thanks, Dave. Mike Rush, is vibratory wear the primary mode of failure? Is corrosive atmosphere factored in also? Could the chain vibration be reduced with some sort of damper? There's guidance within Yorkshire Water about putting these chains in, because the last thing you want, those metre-long chains with the master links, some of the sites, depending on the length of the wet well, you could pull that chain almost tight and just get the last link, the master link, onto the hook at the top of the wet well, onto the wall. But that would then mean that the chain is quite tight, not quite like a guitar string, but the links will be quite taut. And that's really the last thing you want, because then you're pulling the chains against the crook of each other on the short links. And if the pump vibrates, it's the worst case scenario for the chain. So what we try to do is leave 1 meter of chain, as you could, I don't have the presentation on the slide at the moment. The chain hangs down almost in like a semi-loop before it goes vertically back out the wet well. And that is the way we do it, to get minimum amount of wear. From the evidence we've seen so far of the old chains, the legacy chains we had before we decided to do the risk-based inspection programs, the first batch we sent to Germany, the chain was nowhere, and it was good for 2 to 3 years, and those chains have been in between 3 and 4 years, which is longer than our written scheme for normal sewage, for normal SPSs, sewage pumping stations. Sorry, I just forgotten what's the second part of the questions. Apologies. Could the chain vibration be reduced with some sort of damper? Is corrosive in also?
That's not really, unfortunately, that's not really practical. The only thing we can do is make sure that when the pump is selected, that the pump is correct on it, because if the pump's off its pump curve and it's running inefficiently, it can cause vibration or excessive vibration. So really key is a good hydraulic design, good pump selection to make sure it's running at its peak efficiency to reduce vibration, and making sure the chain's not installed too tight.
Yeah.
To minimise it.
Yeah. Okay. Thanks, Dave. William Bowes, you've put your hand up as well. Do you want to come off mute and ask?
Yeah. Thanks, Dave. That was an interesting presentation. I'm in a different industry, but I'm really interested in what you're presenting. So we are at work. We have an ethane tank, which is so we've got our columns are 40 meters, and we have our pumps sitting in 40 meters of liquid ethane. So we use 316 austenitic stainless for temperature reasons. But those pumps, we hope to have them in that tank for as long as possible, because we don't want to be opening the tank up and exposing ourselves to vapor. So I was interested in your what you were saying about vibration and degradation of the the lifting device. We use wire rope, so it's wire rope, but we also have to pre-tension it because we're holding the power cables and the condition monitor cables. But we're in a column of ethane, so I think that the vibration is probably damped by the working fluid, and we also have vibration monitoring on our pumps. And I'm just interested in terms of the factors, vibration and how that would degrade our lifting equipment, because we actually inspect it in reverse. We inspect it after we've removed the pump, and then just before it goes back in, but then we can't inspect it.
And that's exactly the same position we're in, because it's quite unique that the actual piece of lifting accessory you want to inspect is submerged, and the only way of inspecting it is to lift it out, and you can't do your pre-use examination. So the guys are trained, so when they can only look at so much when it comes out. They do an examination, effectively a pre-use examination, before they put it back into the wet well. I don't know whether you could, so using 316 stainless wire rope. I'm just wondering whether it's not, and apologies, the product you're pumping, it's not something I'm familiar with, obviously within the water industry. I'm just wondering whether there's an alternative. We mentioned the blue rope system. So we did not have a lifting at some point. We did not have a lifting chain on some pumping stations, and the only reason we stopped it is because on sewage pumping stations, it was so the blue rope was so ragged up you couldn't even physically use it. It was like a blue rope that's probably 10 mil running through the middle, and a bale of rags that's probably a foot and a half in diameter. So it was just not on clean water sites. It was okay. On wastewater sites, sewage pumping, it was impractical. So in the end, we just said for the number of times we'd be able to use blue rope, and because we've got the risk-based program now, and we know the 316 chains are good, we'll just do away with blue rope. So when we find them, we take them out and put chain in. I don't know how the longevity or the compatibility of the blue or a blue nylon rope with or if it's even practical with the product you have. So I do apologize for that. I'm unfamiliar with the product, but then you won't have to have the chain in there.
Yeah, unfortunately, it's like a minus 90 degrees C, so brittle fracture is
okay.
Hence the reason why it's 316 it's L stainless. So, but yeah, I was just interested in the factors that you were applying in terms of degradation as a for vibration.
I think that's because if we hung that chain in there and that pump never ran, there'd be no risk to it. It could live there indefinitely. It's unlike a piece of normal lifting accessory where if it was in a workshop or a factory or production line, those chains are constantly in use, onload, offload, onload, offload. We don't really have that. Most of our pumps, especially the bigger sewage pumps, which tend not to block, can be in there for years before they're lifted out, and that chain does one lift in probably 4 or 5 years. The smaller ones, maybe once a week, if they get a site that's raggy and that blocks occasionally, or the pump's worn, or there's an issue with it. But generally, the number of lifts is quite low, and we really were interested in what else. If the number of lifts isn't something that potentially is a risk to us, I know any lift is, that we should be looking at vibration. And I think the other thing to mention is that I think the second slide in shows a range of physical size of pumps. And I mentioned that most of our pumps are down at the bottom end of 20, 30, 40, 50, 80 kilos, something like that. It's probably about 80% of our pumps around that pump range. And the smallest chain we put on is 1/2 ton. So we've got a 1/2 ton safe work and load chain with a 60 kilo pump on it. You probably find the chain weighs more than the pump does. So the risk of that is extremely low. And if you take all those factors into account, and when we did the risk-based inspection, we either had a risk factor with a weighting of below 80% of the safe work and load the chain or greater, and it altered the calculation. There's no sliding scale. Does the pump weigh 60 kilos and the chain is 1/2 ton rated? We just either apply below or above 80%. So in theory, if you had a pump that's 60 kilos and a 1/2 ton chain, you could even push it even further. But we didn't. We wanted to be sort of quite conservative to make sure that we were stepping in the correct direction, applying it correctly, not cautiously, but like on a risk base, and then we could always extend it after the first inspection.
Okay, thank you.
Okay.
Great. Kadir, how do you quantify damage level?
Damage to the chain. Sorry, is that what you mean? Damage to the chain links.
Karam, if you're with us, do you want to come off mute and ask the question yourself?
I can, by all means, ask the question. I'll take it that the damage level is damage to the chain. Obviously, when our competent body attends sites, our lifting partner lifts the pump out. They pressure wash it if it needs pressure washing. Some don't, and then they inspect, do a close, thorough examination of every link of that chain. They go from obviously the top link is where the least vibration, where it's hung on the bracket against the opening of the concrete, and where potentially the most vibration, potentially the most wear is where the D shackle attaches to the pump, the handle of the pump, and then the first meter. And obviously, as it moves away from the pump, the vibration decays, it gets less and less. They also measure the diameter, the internal diameter, and the length inside the length of the short link chain, and looking for damage. And as far as I'm aware, when we have the chain catch-up meetings, we always review. We say, is there any damage found? And all the reports are coming back with 0 or minimal wear and no damage to chain.
Yeah. Okay, good. Ali Fordyce, have you seen any interesting results from the 2% audit that you were not expecting? And if so, what was done to follow that up?
No, I know it sounds too much of a good news story, but generally the chains are wearing as we'd expect. Because we had the legacy chains from a previous contract, all our chains were galvanized steel, and the risk of the business was the stainless steel wasn't really around at the time, so everybody had galvanized carbon steel chains, and the risk of the business was they were corroding. The chain was originally, way back when, with the HSC, the chain was originally classed as part of the pump. So like the handle of the pump, it was classed, you buy the pump comes to the handle, the chain's attached to the handle, and from what I understand, a long time ago, the HSC didn't class it as a piece of lifting equipment. So the chain went in, galvanized chain went in, so corrosion happened, and one or two, like I say, we had 1 or 2 failures of pump chains, and then it was changed so that pump chain became an accessory, as it should have been in the first place. So the HSC changed their guidance. It's now lifting accessory. A blanket written scheme went on there. We had a program of replacing all our galv chains with stainless, and from that point forward, really, we haven't really seen any. Even on the 2%, we're seeing that the chains are good, which is what we want. We don't want to put a risk-based inspection program in coming backwards. We never thought we would, because we had those old chains that had been inspected that were 3 years old.
Yeah. Okay. Thank you. Gifford Olney, in some instances, we use a fibre rope looped around the pump handle. Then when we want to lift a pump, we pull a new chain through the pump handle using the rope. Have you tried this, and what are the disadvantages? Sounds like you have just answered.
That is the blue rope system that I mentioned. Yeah. We commonly called it the blue rope because I don't think I really have to say why we called it a blue rope system. It was, other water companies had it. It was the flavour of the month for a while, because obviously when they first go in, they're fantastic because because it's a brand new blue rope. They say nylon rope, probably 8-10 mil diameter. there was a hook with welded eyes on it. You attach the chain hook with a short length of chain on the blue rope, and you basically threaded it like a thimble. You went round until you locked into the handle of the pump, and then you lifted it out. And in reverse, when you drop the pump back in again, you detach the hand. It was a bit of skill and trickery from the top, a bit of sleight of hand, and you managed to unhook the handle and thread the blue rope back through again. It sounds a very similar system. Like I say, the advantage we had on sewage, on raw sewage pumping, so you can imagine what everything that comes through there, that some of these sites, we had to pump the wet well down and go fishing for the pump with a chain, because it was so raggy. The blue rope was not practical for us. Some were okay, some were bad. Clean water was okay. The number of submersible pumps on a clean water treatment works is minimal. Submersible pumps tend to be on our waste side of our business predominantly. So the decision was taken that a lot of them got replaced because they were more trouble than they're worth. And in the end, we say, because of the 316 stainless and the written scheme, that we said, I think it was 2 years ago, I wrote it out of the eng spec and removed the option for blue rope, and we're now 316L predominantly and everywhere within the business.
Yeah, thank you.
No
Kelly Pollock, do you plan to review the RBI assessment for every asset as you move forward? For example, there are A or B defects noted by your inspection body that possibly indicate that your inspection period is not correct for the operating conditions. Would you look at updating the inspection period in or based on the inspection findings? Also, as a second question, have you considered doing the RBI approach with the lifting beams above the pits, as there must be a fair number of them also?
Yeah, so the first part of the question is, that's something we're going through at the moment. So we've got all the data back from the first chains, and we've got second lot of data back from the chains that have been to Germany. We've got about 20 chains that have been tested now. We have the 2% audit chains. We've inspected thousands of chains now, and they've gone back in the ground and been re-tagged for another 3 years or 4 years. And generally, the condition is very, very good. We're looking to actually reschedule and do the extend the RBI now, and that's currently something we're on with.
Okay.
So the second part of the question was, sorry, apologies.
Have you considered doing the RBI approach with the lifting beams?
Sorry, goldfish memory. Yes, we have. It's something that you can do to any piece of lifting equipment under LEAH. So we do have, there's a couple of approaches. We do have some large overhead travelling cranes in water treatment works, which are only used to lift large clean water pumps out, and they last 20, 30 years. So we've been inspecting them every 6 months, put another ticket on it, and it hasn't moved since the last time it was inspected. So we're looking at putting a tag on them that pre-use inspection. When you want to plan to use this pump, we can get somebody to inspect that crane normally within 48 hours. So we could either do a written scheme of examination, or we can literally park it and basically put out of date on it, call this number, email this person, and we will have it inspected prior to your use. It doesn't mean we'll have it maintained as well, but it's no point inspecting it every 12 months, being a lifting machine, when it's not needed.
Yeah, okay. Gifford again, if a chain is in poor condition, do you have a way of changing the chain without entering the confined space?
If the chain's in poor, what we used to have before with the galvanized chains is that with our health and safety and with our reps and operations and maintenance, we can do what's called as a safe lift. And this is basically, we have a risk assessment. We've got a set of RAMs, risk assessment and method statements, that's written in such a way that we deem the chain will fail. So we write and put mitigation in place based on thinking that the chain will fail. So it's attached, a crane or a chain block is attached, an electric one, and people stand well back. The big advantage is that load, the load that you're lifting, is always below your feet until the very last 3 foot where it goes over the handrail or through a gate. So the risk is minimal. If the chain fails, the pump goes back into the wet well. Yes, I accept that's not ideal, but we are not stood anywhere near the load, and we are stood well back, and it's what we call a controlled lift. Or what we can do, if we can, we will fish for the chain. We've got a fleet of large HIABs with very good reaches on them, and there's numerous times that we can actually lift the pump by fishing with a hook and attach it to the pump handle and lift the pump and the old chain out as one. We can do a control lift, but we prefer not to for obvious reasons.
Yeah. Okay. Yeah. John Holmes says, has a chain ever failed, and if so, what was the consequence? You've sort of mentioned a little bit there, but
we've had a failure of a galvanized chain. One of the master links failed. It was an old, before submersible pump lifting chains that you see on the presentation and that illustration of the short leg, intermediate and master links every meter. Those chains are now manufactured by pump chain manufacturers purposely and for the sole purpose of submersible pumps. Before that was done, people used to get lengths of normal short link chain and hand make master links to go through them. And what we've had in the past is a failure of a master link because it was just very, you could see that the short link chain had been machine made and the master link had been handmade, and it was very poor quality, and it caused the failure caused the drop of the pump.
Okay.
That doesn't, they're all stainless now.
Okay.
Gifford come back with a comment, but I think it's referring to the previous question, and I believe you answered that. And then Philip Ashcroft, again, hi Dave, you are correct with how the HSE originally categorised the pump chain as part of the pump. There was a test case with one of the other water companies that led to the change to accessory for lifting non-mixture for pump chains, and why we at Yorkshire Water had to look for other options.
Right.
So the original blue rope system to try and demonstrate we were addressing the issue.
Excellent. Thanks, Phil. I knew a little bit of the history behind it, but you know, that's excellent. Thank you very much, Phil. I'm glad you're here. Nice to hear from you.
Yeah. Okay, that's exhausted the questions on the chat. We are almost up for time. Does anybody have one final question before we go? No? Well, yeah, just a huge round of applause and massive thanks to Dave, please, everyone.
Thank you. A fascinating subject in its own right at times.
Yeah, lots of people thanking you in the chat, Dave. So
thank you very much for that. Much appreciated.
Yeah, thank you everyone for joining and asking some really interesting questions. And Dave, that was fantastic.
Not a problem.
Really appreciate that, and I've learned a lot.
Who would have thought that sewage pumping would be so exciting?
It is. Yeah. Okay. All right. Yes. Thanks, everyone, and have an enjoyable evening. And
fantastic.
I'll speak to you again soon, Dave.
Yeah. Take care. Thanks, everyone. Have a good evening. See you later.
Bye.
Bye.
Thank you.
Thank you.
Ding.